Okay, now today we go into chapter 6, differentiation. So it's a very long chapter. So we break into 3 parts for this chapter. So we try to cover these two, differentiate a common function. Then we try to look at curve. Then we break into the second half, which is differentiate a product and quotient, and differentiate by substitution. This is the second part. The third part is we'll do successive differentiation, rate of change, turning point, and small changes. Right? So your final, there's one question on this part. This part. Okay. Yeah. sorry, this part. Okay. Huh? Sorry. Sorry. Okay. Means you need to prove whether later I'll emphasize more when we come to that particular topic. Yeah? Okay. Okay. So why it's important to learn differentiation? So you will see differentiation in static dynamics later, which is you need to differentiate the stress on a beam, right? And if you deal with temperature in chemical reaction, sometimes you need to differentiate. And you need to find the rate of the speed. Rate of the speed, if you change distance, differentiate with time, you get velocity. And you differentiate one more time with time, you get acceleration. Okay, so this is the rate. Then sometime in the electric current, electric circuit, you need to find the current by differentiation. And this one will be in your aerospace design module. You need to find the torque of the turbine blade. Okay. Okay, so these are the example. These are example that you will see in your final year. So you need to use a software, for example, ANSYS, to simulate things. So when you use a software, you should able to explain why you can get a certain colors or certain value there. Huh? All right. Okay. So before we go deep into differentiation, so there are some background, like for example, law of indexes that you learn in chapter 3, right? Law of indexes. So this you need to recall back, right? For example, if you take a power m multiply a power n, you get a m plus n. Okay, if you divide the same base, you get m minus n. So this one you need to recall back. So a power 0, you get 1. And if you have bracket power n, you need to multiply them. And then you have an index of minus is actually 1 over something. And you have 1 over n is, if you 1 over n, that one is square root n. Okay. So this one you need to recall back when you do differentiation chapter. Okay. So this is important. So pass back to those come in, right? Okay. So under calculus, those that you come in with a diploma is fall under calculus. So calculus, you will cover differentiation and integration. Yeah. So when you do credit transfer, calculus is only 50% of the credit transfer. So you need to take another mathematics module for full credit transfer for engineering mathematics 1. Okay. So we start, yeah? So what we mean by a function? Function means there's an equation that relate 2 unknown or 3 unknown. So for example, the one that you see, y equal to 3x squared plus 2x minus 5 is an equation that link y and x. So you can write, or in other module, or in a higher level of mathematics module, we will write y equal to f bracket x. Means y is in the function of x. Okay, it means that y is defined by x. Okay? So from now onwards, you will see sometimes we use fx. All right. So some lecturers, they like to straight away use function f, right? Fx equal to the equation that belongs to that relationship. Okay, so this, if you see f bracket x, is called functional notation. Functional notation. Sometimes the question asks you to simplify the equation in functional notation. Means that you need to write in fx and not y. Okay, yeah. Okay, so which means that you can substitute the x value every time you write f bracket x. So for example, if you want to find the relationship when the x value is 0, you write f bracket 0 straight away. Yeah. And so on. If you want to emphasize x equal 2, then you write f bracket 2. Okay, so this is functional notation. Functional notation. Okay. So how you write when you answer question in the differentiation? So sometimes you need to substitute value. You need to write when x equals something, when x equals 0, double dot, then write in the functional notation f bracket that x value, and then substitute the x value inside the equation. Okay, so this is the way you write in functional notation your answer. Okay, and so on. Okay, if it's x is 2, you just substitute. Okay, this is just a quick exercise. So if you can see, you're given a function which is 4x squared minus 3x plus 2, and the question asks you to find x equals 0, x equals 3, x minus 1, x minus 3. This one is equation which is x equals 3 minus x minus 1. There are two functions here. Okay, so I think this one should be no issue. Just substitute the value. Okay. Only the last part, you need to find individual function first. Then only you complete the equation. Okay. For example, function 3, you get 29. Function minus 1, you get 9. Then you rewrite the equation again. Function 3 minus function 1 minus 1, you get 29. Okay. 20. Okay. Any questions so far? No. So far it just tell you what is functional notation. Okay. Just a recap. So I think the rest, if you understand what actually it means, you should able to do. So basically, what you see in the bracket, you just substitute inside the x. I think something wrong with my PowerPoint. Right? The one that I give you is the more popular one. Okay, so there are some presentation wrong with my PowerPoint slide, but you refer back to your tutorial question that I just give you, right? So this one, you can go home and have a look. You can check your answer after that. Okay, so this practice question, you can go home and have a look. Okay. Okay. So any question for functional notation? No, just substitution of what is given the x. Okay. Okay, so we come to the more important part, which is the gradient of the curve. So as you learned in the previous basic mathematics, right? So if you're given y-axis and x-axis, right, and you plot the value, okay, and you plot the value, you will see there's a trend between the data. Okay, so they are linear data, quadratic data, polynomial data, and so on. Okay, now we just take maybe a quadratic curve. We give you this presentation that you see on the screen here. So here you see function f. This is y. Yeah. So from this chapter onwards, remember, we no longer use y already. Yeah. We start to use functional notation already. Yeah. Okay. So those coming late one, you need to recall back what is recorded lah. Okay. So this is a curve, right? So what I mean by finding the tangent? Tangent is when you do a curve and you draw a line. So the tangent of the point P, right? So it's actually a 90-degree to that curve. Huh? Yeah. Meaning there's only one if on the curve. If we mention finding the tangent, means there's only one touch point on the curve. There's only one contact point along the straight line. For example, this straight line PQ, it will interact with the curve on one point only. Okay. So if we have a straight line, we know that when we can define straight line with y equal to mx plus c, right? So this is should be familiar. Straight line is y equal to mx plus c. Here we further upgrade a little bit this graph into more complex. So just now we have the curve, and now we label point A and point B. Point A, how you find point A is you project the point to the y-axis and x-axis. So point A is x1 and f bracket x sub 1 is not y1 anymore. So of course you write y1 also correct lah. But because this is differentiation chapter, so you should write function notation. So f bracket x1, or you can write y1. So B also same. B is x2, y2. This should be very basic. Yeah. Okay. So in functional notation, we have mentioned previously, y1 equal to function f x1, y2 equal to function x2. Okay. So you know that how to find the gradient of this line, y equal to ms plus c. How you get this gradient? You take the difference of y divided by difference of x. Right? You take this distance divided by this distance. So how you, on the graph, how you find BC? BC, you take BD minus CD. How you get AC? Just x1, x2 minus x1. Okay, or the distance of ED. Okay, so this is quite basic. Okay, so as we go deeper, you need to again write in the functional notation. You need to write in functional notation. Function bracket x2 minus function bracket x1 divided by x2 minus x1. Okay. Yeah, basically just finding the gradient. Okay. Again, this is important for your final exam. Okay, so if you have a curve of a quadratic equation, function x equal to x squared. So x squared, in front, the x squared is positive value, which is 1. So it's a smiling face. And no intersection point, which is at 0. So it starts from 0 and then small curve. Okay. So the gradient of chord AB, if you're given to this graph, the chord AB is the difference of y divided by difference of x. So you should be able to find the concept is still the same. Yeah. Okay, as I highlight on the screen, right? You want to find the gradient of AB, you find the y dash line divided by x dash line. Okay, you can ignore the value, but the concept you should be able to understand. Understand the concept. So in this case, you write function 3 minus function 1. Why 1? Because x is 1 here. Yeah. Or even though on the graph there is no 1 there, in the presentation you should write in a functional notation, f bracket 1, because x value is 1. This one y3 because x value is 3. And because on the graph you don't know the value here. Yeah. Then how you get 9? You substitute into the function that you learned 5 minutes ago. Okay. Function 3, substitute into here, you get 9. Function 1, you get 1. And at the end, you get 4. This is the way when you want to get the gradient for that graph. Okay. Okay. How, if you understand this one, if you understand how to get the gradient for AB, you should be able to understand if the question asks you to find the gradient of AC. It's the same. Yeah. Stop me if I go too fast. The concept still same. I just switch the location of the point. What I want to highlight here is the way you write functional notation in your answer. Okay. So this is how you get gradient of AC is 3. Yeah. And if you understand the previous two examples, if the question asks you to find AD, also the same. AD, you should take function of the y, right? Function 1.5 minus function 1 divided by 1.5 minus 1. Okay. Functional notation is useful when you don't know the value of y on the graphic or on the graph. Okay. So another situation, if you want to find a scenario along the curve of x squared, you pinpoint, let's say a pinpoint of point E, right? So point E, you are given 1.1. And then we put in the function 1.1 here, which represent the y coordinate. So you apply the same, you'll get 2.1. Okay. Now, what we're trying to show you here? On a curve, a quadratic curve, just now we have a long chord, which is A to B. And then we shorten the line, which is 4 along the line. AB become AC, become AD, and the value becomes smaller and smaller on the X. Then we get AE. What happened to the gradient? It becomes smaller and smaller, yeah? So again, another f is smaller. You try to find the gradient of smaller that is very near to point A, you'll get this value. Just now, you get 4, 3, 2.5, 2.1, and is it 1? 2.01. Okay? Yeah. So should be the value wrong already. Okay. All right, but I mean the AE should be after AD, but you can see the value is dropping. Okay. So what do you see here is as you close to your target point, B moving to C, moving to D, moving to A, your gradient is close to one value. In this case, it's 2. Right? This is along the function. So what does it mean? It means the smallest value that you can get when you find the gradient. The mathematics term is called limiting value. Means no matter how far you go to find the gradient on the curve, there's one minimum value that's always there. In this case, 2. Okay, that 2 we give a name, is called limiting value. Okay. So okay, so far it's just finding the gradient. The rest is your exercise. Okay. We start to apply differentiation, okay? Okay. You will see this kind of presentation in other engineering core value. With this, you will see this delta form. Delta form means small changes to that particular coordinate. Okay, but the concept still same like the previous one. Okay, the concept still same like the previous one, only you substitute the value inside the equation. Yeah. So, so A and B, they are 2 points that are very close because they only different by delta. Delta X and delta Y. They are very close. Okay. So if you want to find the delta, find the gradient of AB, this one. If you do the calculation, at the end, you arrive at delta Y divided by delta X. Okay, which is the distance of your delta Y divided by delta X. Okay. So this delta, it means very small changes, very small. So, and we know how to find your delta Y. You find this distance. You take the long distance with it f bracket x plus delta x divided by fx with this equation, right? So if you take delta y divided by delta x, you substitute this value f bracket x plus delta x minus fx on the top of the equation, then write the delta x. Okay. So you can see as delta x, this one approach 0, means it's approach to very small changes with it near to 0. Del y del x approach a limiting value. Okay, and the gradient of the chord approach the gradient of the tangent at A. Yeah. Meaning this one, this delta small changes near to 0 means A, B very close. Right? So we can get that is actually the tangent value for A. Okay. So if the question asks you to find gradient of a tangent on a curve, so there are two notation, right? One is this long term. This is on the graph that have very small changes, especially when you learn in your third year, fourth year aerodynamic classes. So you will see very small changes at the flow of the wall. You magnify it, and then you see what happened to the flow when the molecule of air touch the wall. Okay, so you write limitation, limit your delta x near to 0. So the whole function you can write like this. There's one, this one is for your reading. It's for your reading. I won't test you. But there's one term called Leibniz notation. What I want you to see is this one. F comma. F comma is you differentiate something. You have one comma means you differentiate one time. You have two comma, differentiate two times. You have three comma, differentiate three times. Okay, the rest you can just observe. We're not going to test you, but this is just explanation of what is f comma x. Okay. So you have two notation. Either the one that you see, if you change the delta x, with this very small x near to 0, you can change the delta to d. The d means you can measure with your ruler things that you can measure. So in mathematics, you can change things that you're unable to measure to things that you can measure by limitation near to 0. By this limit. Yeah. So sometimes the question give you delta. The trick is actually force you to convert into dy dx. Actually force you to use this Leibniz notation. It's like law of logarithma and so on. If you see something that has exponential you're unable to solve, you apply log at both sides. So this is also the same. Okay, so I want to highlight here when you have a delta x, delta y or something, you want to change it to things that you can measure. You have the limit, you apply the limit, then you change to dy dx. Okay. So this one, if you see f comma dy dx, they are called differential coefficients. So if you in the question, if it asks you to solve the differential coefficient, means ask you to do dy dx. Okay, or the question will ask you to find the derivative. It means also you need to find dy dx. Or f comma or f. So there are two things. Okay. So this is just an introduction to dy dx that you're already familiar, right? So just need to highlight when you can change delta x to d, you need to apply the limit. Limit dy dx near to 0, then you can convert the function into dy dx. Okay, so this is very important. That's why I box it. Okay, so let's have a try. Differentiate from first principle means you differentiate one time, dy dx. Determine the value of gradient when your x equal to. So first principles again means to find f comma. You only have one comma or dy dx. So you write something like this. you write f comma x equal to limit delta x near to 0. Then curly curve, the difference of y divided by difference of x. Then you know that your fx equal to x2. You substitute x plus delta x, right? Meaning this one, you substitute by this one, right? So you get bracket x plus delta x superscript 2. Then you expand the bracket. You get quadratic equation, which is x squared plus 2x delta x plus delta x squared. Okay, so this is what you get just now. Huh? So you get this one. Okay, you substitute this whole thing inside here. You know that fx is x squared. So copy x squared here. Delta x copy. You can cancel. Right? So at the end, your f comma x, you'll arrive at this one. So again, you can factorize the delta x in the curly form, right? You pull the delta x out, you can cancel. Again, when you cancel, this one become 1, not 0. You have something below there with this 1. If you put 0, become infinity. Okay, so at the end, you get limit delta x to 0, curly bracket 2x plus delta x, and you know that delta x is 0. The answer is 2x. Yes. This one, this whole thing, substitute here. How you get this one is from the previous one, this one. This one. Because this is x, right? So you know that your function is x squared. But now your f function is x plus delta x. So you calculate what is x plus delta x by using the function. Okay, so from there. Because in your equation, you need to find function bracket x plus delta x. Okay, at the end, we arrive at what you're familiar with is 2x. You know that by your mind calculation, fx equal to x squared, you differentiate one time, it becomes 2x. Right? So in the exam, if you straight away give me 2x, you miss marks for all this point. Maybe the answer only 1 mark. The question is 5 marks, so you only score 1 mark. Because it's asked you to use first principle. Yeah. So this is something but the concept still same, right? It's still dy dx. Just now we're dealing with the small changes of delta x. Yeah. Okay, so this is how we do, right? So if we get so 2x, and they ask you to find the gradient at 2. So you know that this f comma is gradient, is dy dx is gradient. So you just substitute x equal 2, you get 4. Okay. So the answer is 2x, f comma bracket x equal to x, and another answer is 4. Yeah. So it's only what I need to stress here, you need to recall back the limitation delta x to 0, that one. Okay. Okay. So the rest is still the same, right? Still the same. Yeah. So again, this formula is important. If you straight away give me 5, you only have the answer for 5. If you don't give me this one, the step for solving the coefficient will be, I cannot award you with that marks because you do not show the understanding in using first principle. Okay, all right. So the rest is still the same. You can read it when your revision time, if you understand the previous one. Yeah. All right. Any question for the first example? No. Okay. Okay, the rest is still the same. And sometimes, yeah. Okay. So another tricky question, it will ask you, give you a numbers, where you know that if you differentiate a number, what you get? If you y equal to x, dy dx, what is the gradient of that line? What is dy dx if you have a straight line? So what is the answer for dy dx? 0. You should be able to draw the so x is 0, but how you prove is 0? Now you're taking mathematics class. In other module, you can straight away answer 0, but in mathematics, you still need to prove it. Okay. So there's no x value. So you're just substituting x plus x0 for x, right? Yeah, because this one is x no value, 0. Then you have a limit near to 0, still 0. Okay. So this is how you write. Still the same. You only need to expand the y equal to fx plus delta x equal 8. And then you differentiate it, substitute inside this first principle equation. Right? Limit delta x to 0. You know this one is 8. Right? This one 0. Delta x 0. This is how mathematically you prove is 0. Yeah. Okay. So if, yeah, this one already draw the whiteboard already. So what does it mean? It means if you find the coefficient or derivative equals 0, meaning you're looking at the straight line. If the question like want to give you a tough question, it just give you some hints like the aircraft is having a derivative of 0 or having a dy dx of 0, meaning it's flying in a straight line. Okay. Yeah. So this is some hidden point that you should able to extract. When you see dy dx 0, it means you're having a straight line, a flat straight line. Okay, the rest you go home and have a look. It's still the same, right? If you have a question, come and see me, right? But still the same. This formula is important. So you should always remember this one. dy dx, f from x, then you find limit x 0, curly, and you substitute the value accordingly. Okay. It's quite lengthy, so go home and have a look. Also same. This one also same. So using the principle. First step, copy the equation. Second step, do the x plus delta x by substituting this x as x delta x in this equation. Okay, so this one x become x plus delta x squared, then you expand the equation. After you get the equation, you substitute back to this, again, this general first principle equation. Then you summarize or you rearrange it, you get that answer. Yeah. So in the test, you can just cancel, use your pencil, just cancel like this. Right. So at the end, so because limit x is 0, so you can, this one near to 0, so you get 8x plus 5. Again, in the test, if you straight away give me dy dx equal to 8x plus 5, you only get marks for this part. Okay. Just now, the first principle is a bit lengthy process, but nowadays already replaced with computer. Algorithm already help you to do all the things already. So in reality, we don't have to do the steps, right? So this is just an exercise. So again, if you see first principle means you need to show me these steps. Okay. But in real life, we don't need to use first principle. But fundamentally, you understand why you can get that particular answer. You should be able to answer, oh, I use first principle, then because I can change the small changes to dx, and I have a limit of delta x to 0, so I cancel out the small changes. Okay, this is how you answer, right? All right, so I think we come to the end of the question, right? Is it the, I think so. Okay, so now we look at, just now we look at a very simple y equal to x squared, y equal to mx plus c, straight line, quadratic curve. Now we look at y equal to ax power n. Okay, so when you have a power n, again, we start from this section. You don't need to go back to the first principle anymore. Straight away, apply this formula. Okay, so if you have a y equal to ax plus n power n, dy dx will equal to maintain the constant value. Maintain constant value. Pull the exponential to the front, and then because it's differentiate is -1. You need to take away 1 from the n. Okay. So dy dx is -1. If you do integration, is +1. But for differentiation first, dy dx equal to n-1. X power n-1. This one should be easier. Okay, so what I need to highlight is that remember to change into functional notation. Y equal to f bracket x. And f comma means you differentiate one time. Yeah, or you are finding the gradient of that curve, of that graph. Okay. Okay, I think this one you already know already. It's just the notation. Need to highlight the notation. Okay. Okay. Now you know that y equal to 3x power 2 dy dx, you know, is what? 6x, right? So so if you if you write like this, dy dx equal to 6x, you can write f comma x equal to 6x, mean this one is the gradient of that curve. Right? Gradient, or sometimes the question asks you to find differential coefficient is 6x. Lah. Okay, differential coefficient also dy dx, also f comma x. Or sometimes derivative also same meaning. Sometimes mathematics in your answer script, you can write d dx bracket the y. You also get x. Okay, there are a few presentation. One you can write dy dx. One you can write f comma x. One you can just write a full sentence differential coefficient derivative. Or another one that you see in fluid mechanics later, you need to use d divided dx bracket the y. It's also mean dy dx. It's just that you write the d dx to the front. Okay. Okay, so you see the difference? Now it asks you to use general rules. General rules mean you don't need to use the delta x, that one, the first principle. If you see the question asks you to use general rules, means you straight away use this one. Mean you need to write this formula. If you give me the general formula, only the first line or second line will do. As long as you understand what formula you are using, you can write if y equal to a xn, then dy dx equal to a n xn minus 1. This is important. It's got marks one. This one, general equation. If you write, you got mark. Don't write, don't have marks. But many times you get a question marks in the question, how you get this one. Okay, so just by a quick look, you know how to do already. So y equal to 5x7, what you get? Dy dx, what you get? 35x6. But again, remember to write this general equation before the answer. So this one, remember to change square root into power 1/2. If you see 3 beside the head, then it's cube root. But this one is 3, right? That one is 3, right? 3 in front, right? So remember to change the root symbol into index. So this also same. 4 divided by x squared, you can write it 4x power minus 2. Convert into index form first. So that's why in the first slide of this lecture, I remind you to recall back the index chapter. Yeah, something like this. So you need to change something like this, then you do dy dx. So see, this is the way how you answer for differentiation chapter. You write dy dx equal a n x n minus 1, substitute the value, 3 bracket half x 1 minus 2 minus 1, then you solve the question. Okay, right. Okay, the rest I let you go home and have a look. This also another one, but still concept is a bit long. This is only want to test your careless mistakes. Some of you, especially when you see this one, square and 5x. So you should write in x 5/2. Okay, and so on. Okay. Yeah, the rest still the same. Only I need to highlight to transform the head into index form. Okay. Okay. Sometimes you get question differentiate y with respect to x. It means still find dy dx. Okay, dy dx is simple. What is different when you come to trigonometry? Differentiate sine, differentiate cos. That one a bit difficult for me lah. I'm not very good with angle. Okay. I think this one is it inside your tutorial question? Yeah. Okay. Okay. All right. So we go into graph. So this one is another one. We already complete y equal to axn formula. So what happens if you differentiate trigonometry function? We will see in engineering lah, because especially vibration and so on. Okay, so just give you a general recall. Sine graph look like this, y equal to sine theta, look like this. Start from 0. However, the x is in radian. Radian means in pi. 360 degree is 2 pi. So when you plot a sine graph, you are actually using y versus radian axis. And it look like this. So 0, 90 degree, 180 degree, so on. So this should be, we'll assume you know already. Okay. What happens if you shift the graph? This one is in electronics, in avionics later. What happens if the electronic signal shift plus delta theta? So you shift the graph, this part, right? You shift the graph, this whole graph, you shift plus, right? Means it shift like this. Means the whole curve, you shift like how many degree lah? Okay, so in this case, you shift 90 degree. Yeah. So these are the things. So if you, okay, so the first one is y equals sine theta. The second one is when you do dy dx, or in this case, dy d theta. Dy d theta, the graph flip, cannot say flip lah, but it become a cos graph. Cos graph start from 1. Cos 0 equal 1, right? Okay, so it start like this. So these two graphs is important. We assume you already know. Sine graph look like this, cos graph look like this. When you differentiate sine, you'll get cos graph. Okay. The rest you read lah. Okay, so at 0, gradient is positive and is at its steepness. So this one is go up. But at this point, if you differentiate this point, it become maximum positive. Right? And so on. But anyway, what is important, I want to show you the general equation. Yeah, okay. So the rest you read. Okay, this is important. When you differentiate y equal to sine theta, dy d theta, you get cos graph. However, if you differentiate sine graph with a means in front the a is there's a constant value of theta. Dy d theta, you need to move the a to the front, and sine become cos. Continue the a theta. So this is the first equation. If you differentiate a sine theta, you get cos. You differentiate y sine a theta, you get a cos a theta. Okay. So what happens if you have bracket a theta plus alpha? Same, if you have anything that have constant value, you pull to the front. You pull the A to the front because theta and alpha is angle. You just maintain. The bracket one, you do not touch it. You just copy. Change the sign to cos. These are the important slides for sine graph. If you differentiate, right? Okay, what happens if you reverse the process? This is sine graph. If you have cos, you will reverse. So okay. So this is cos graph that look like this. If you differentiate this one, it will shift to right hand side. It will shift to the front again. The whole graph will shift to the front. So you get a sinusoidal shape again, right? So you're displaced by 180 degree. Yeah. Okay, so the graph, I think a bit confusing for some of you, but what is important is this formula. Y equal to cos theta. If you differentiate cos graph, you again is negative. There's a negative sign there. So this is the careless mistakes. Almost every time we'll have students forget this one. Negative sine theta. The rest is the same. If you differentiate y equal to cos a theta, you still move the constant to the front. Don't touch the a theta. Change the cos to sine. Okay, the rest is still the same. If you bracket a theta plus alpha, don't touch the bracket. You look and see if any constant, put the constant in front. Change the cos to negative sign. Yeah, so this is important. A bit confusing when it comes to sine and cos. Okay, let's have this exercise. Then I think we have a short break. Okay, so if you have y equal to 2 sine phi theta and cos 2 theta, so you know that sine you differentiate, you'll get cos. 5 you put to the front, right? So this one cos you differentiate, you become negative sine. Pull the constant to the front, right? So the rest is so you write. Copy the question, y equal to something, then second step, write dy dx, dy d theta equal to the general formula, pull the constant to the front, you get 10 cos theta. So this one is function of time, although it's not angle, but it's involved with cos. So still, you continue with the trigonometry approach. Pull the constant to the front, then cos become negative sign. Don't touch the 2t. So you write f comma, right? The answer is negative x sine 2t. Now, if the question give you y equal to something, if the question give you y, don't write f comma. If the question give you y, you need to write in y dy d theta. If the question give you f function, you answer in f comma. Okay, follow the format. Okay, so this one is more 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 towards the test standard, where there's a combination of sine and cos. Okay, now how do we do this? Again, this is plus and negative. Later, in later chapter, you see there's a bracket between sine and cos, meaning it's multiplication. That is another approach already. Okay, so here, you dy dx, you see it as a two function. You see it as two functions. So what you can do is you do one set first and second set, and then you do. If you scared that you do confuse that, but this is how you write dy dx equal, and then sine change to cos. The constant put to the front, remain the 2x. Then move to the cos, copy the negative, pull the constant to the front. Cos become bracket negative sine 4x. Usually the negative sign is missing when you convert cos to sine. Okay. So careless mistake, usually the cos differentiate to sine. Just take care of that. Okay, the rest is just substitution and a rearrangement. So you can stop at here. The next step usually is the substitution, with this application question. Ask you what happened when the x is certain value. Okay, so this is another presentation, right? When you see pi means in radian already. Okay. So when you apply this one, the third equation, when you see bracket inside there got a theta plus alpha. Okay, so this is the example of the third equation. So the rest is still the same. Sine will become cos, cos will become negative sine. Then pull the constant to the front. So for example, the first one, okay, you only pull the constant in front of theta. Then you rearrange. Second part also the same. Cos becomes sine, but it's negative sine. Like this, cos become negative sine. Okay, should be no issue so far. How many pages more? The last page already. Last page. One. Okay, we go through all the slides and then we call it a day. I mean, one more page only. Okay. Okay, so this one, you go home and have a look. The answer is inside the slides, right? So this one is in the circuit design or your avionics chapter that calculate the voltage. Okay, so the change of voltage means what? dV d theta or dV dt. This is in the t form. Okay, dV dt. So same, sine become cos. Then the constant move to the front. And the rest remain. Okay, then substitution. T equal what? T equal what? Okay. 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 We go to the last part, and then we call it a day. A bit lengthy today. Right, but we call it a day. After we do y equal to e which is the natural frequency, e power ax and ln ax. How we do differentiate? Yeah? Okay, this is the presentation graph. If you plot y equal to ex, right? You plot this one, and you differentiate. You see, below one is a differentiate graph. You differentiate any different? It's the same. Huh? If you exponential e exponential s, you differentiate, you get the same graph. Same graph. Huh? Okay. So this slide is important. So y equal to e power x. If you do dy dx, you still get ex. However, if you get e power constant value x, remember to pull the constant to the front. Then remain the ax. Like the previous one, same. Huh? Yeah, copy this one inside the slides. Yeah. Okay, dy dx, ex equal to ex, y equal to ax, dy equal to aex. Yeah, right. So what happened if you have y equal to 2e 6x? What's the answer? Dy dx equal to, so it's what? 12e power 6x. Yeah. Okay, nah? So this is how you write lah. Dy dx equal to 2 bracket 6e power 6x equal to 12e 6x. Again, what is important is the one that I put in the red box there. Formula won't be given in the final exam. Okay, what happens if you see ln x? Ln x, if you differentiate, it becomes 1 over x. Mean whatever you see the x, 1 over that value. Okay, what is important is these slides. Y equal to ln x, then you do dy dx equal to 1 over x. So same if you have ln ax, you do it, pull the constant to the front. Okay. What is same for? Okay, so a for ax ln is a bit special case. Put an extra mark there, so we do not carry the constant value. So for example, if you have y equal to ln 4x, you do dy dx, you still get 1 over x. Okay, put a extra mark there. This is also one part of the careless mistakes. Because you have so used to carry the constant to the front. So when you do ln ax, be careful. You don't need to carry the constant. Yeah? Okay, so here you should be able to do, again, what I need to highlight is when you have 4 divided by 3e 5t, change this one into index form. Eh? You can pull 4 over 3, then pull the e right as a e negative 5t. Then do the dy dx. Okay, the answer is there. But as long as you understand what is the previous slide mentioned, it should be okay. Okay, this is for your revision. Eh? Okay, so what happened if we have ln 3x become what? So again, we have ln 3x, you don't need to carry the constant value, but the front 5 you still need to carry. It's just that the ln bracket, that one you don't need to carry. you carry you plus b. B is what? Constant value. If it's unknown, then there's another method later on. Yeah. So we'll do substitution later, U and V. Yeah. Okay. Okay. So I think we come to the last page of the tutorial question. So too many info for today. So we have covered only the first part. This chapter I break into 3 parts. So we have cleared the first part. So next week we try to conclude differentiation. Then another weeks we complete, yeah, so that we have time to do revision. Yeah. All right. So dismiss the class. So see you next week.